Hi everyone, Rodrigo again. I'm here to talk about the new features and roadmap of ZBus since the last session I did on Prague last year, right? And I'm going to start with why ZBus, right? We started ZBus in the past because one-to-one communication is easy, right? We have a lot of kernel objects or tools that enables us to make that kind of thing. But when we start thinking in a more complex way, or for example, one-to-many, we don't have so much options. And for example, here we just have mailbox, and you need to do a lot of manual things there to make that work. So it's not easy to do that. And even if you think in a many-to-many communication topology, it's really hard to do. Even if you are thinking a two-way communication, for example, here we would have a lot of queues or FIFOs or something, right? It's not easy to do. So we brought the bus here. The bus enables us to make the threads talk each other in one-to-one, one-to-many, and many-to-many ways, right? And this is the current status of ZBus, right? We have two kind of subscribers and one kind of listener. We have two kinds of subscribers and the listeners, and now we can publish two channels through ISRs, right? Which is a new good thing. And one of the advantage of use ZBus is the decoupling. When we have communications, we have a coupling between from the producer to the consumer. In this case, we can think in three more general couplings. Space, when the producer needs to know the consumer. The time, when they need to work at the same time to make the communication work. And the synchronization, which means that the consumer cannot do anything other than wait for the communication or act during the communication, right? With ZBus, mainly for the subscribers, we have total decoupling. They don't. The producer doesn't need to know the subscribers. They don't need it's not necessary to have the same the communication at the same time, and then the subscribers can do a lot of different kind of things. They don't need to wait the communication to act. Okay. For listeners, as we need speed and we need to be more fast. In fact, we have just because space decoupling is one of the most important ones, because the consumer, the listener, doesn't need to be known by the producer, but the listeners cannot just run during the publication process, and they cannot process other workload than the communication, right? So they are fast, but they have some limitations about that kind of thing, but it's a trade-off. You need to pick up what you want. So the contribution statistics from ZBus, I took some, I did a query there, and since last year, June, we had 28 pull requests. We have 3 from the community, other community members, and 25 from myself. And thank you the community for contributing and help. I would like to see more people involved on that, please. We have a lot of things to do, and I am only in Portuguese I say eu keep. It's my I only keep team. I don't know. And for that, going on, we have 3 core features during this year. We have 3 core features that are interesting to tell you. Okay. And other improvements, documentations. I did refactor the benchmark sample, which is a really big one, and you can do a lot of things there. I improved some C++ compatibility and fixed some small minor issues and things like that. Okay, but we are going deep on that 3 core features. So, beginning with the observer storage. At the beginning, For example, here we have 2 subscribers and 2 listeners, and for that, during the channel definition, we would have a kind of list with a new ending list or array of observers. And if we take the channel struct as a row on a table, we would have this kind of thing here. We have one value for each column, but for observer, we would have a list, which is not a good way to organize data. And taking some database or good practice, normal forms and things like that, I separated them in a different table or struct. So now we have just the channel definition, and we have an object or a relationship called observation right now. The observation is just a reference to the channel and to the observer. And now we have an additional enable flag that enables us to make that enable or disable individually, which is good, and it gives us a lot of flexibilities. And the best part of it is that we can define observers, static observers, in separated files, in different files. Before we could just have static observers during the definition time. So all the observers here would be static, and they were part of that array there. But now we can use the ZBus channel add observer to add that relation in a separated file. So here we are decoupling or making the space coupling less coupled, in fact, with the channel. We are not talking about consumer producers, but we are talking about channel observers. Now we can add observers without intervenience of the channel, so which is good for modularity and other things that make your code more separated, right? So we can have that kind of thing, and to make sure that the sequence of the delivery notification sequence was kept, I added a priority sequence number here, which tells a VDD, the virtual distributed event dispatcher, how to notify the observers, right? So here we have, for example, the VDD will notify first L1, then S1, and then L2, and then S2, right? Because the numbers. We are increasing it. It's not a priority manner in the opposite sign, right? We are using that in that direction. In this case here, if we use 3 for both of the observations, we could have the same result because we are using lexical order additionally to the number. Okay, so it's just a tip, but now we can define static observers spread out. It's good, and you cannot. It's not necessary to rely on runtime observers using I don't know heap and things like that. Okay, for whom that are trying to use Misra C or something, this is a really good thing to do. And another benefit for it is before we just have the enablement on the observer, right? And now we can disable observations individually. So you can even disable the subscriber at all as a whole, or you can disable just one observation. It can be static or runtime or runtime observer. Both can be disabled on the fly, in runtime, right? So you can do that in a more granular way, which is good because you can keep your subscriber enabled and just disable some channels which you don't want to receive notifications at that time. So for that, we have, in summary, we have static observers in separated files, individual masks, right, which is good, and a sequence priority to make the notification sequence as we want, okay? Master subscribers. The master subscribers were requested since the beginning, and I was trying I was reluctant to add them, but I tried to find the best way to add them to ZBus. And in fact, the message subscribers are subscribers that receive a copy of the message. Before, we just have listeners and subscribers, right? The listeners were executed by the VDD, and during that execution, they could access directly the message without needing copy or something like that. They could access directly the message, which is good. And the subscriber only receives the notification of a changed channel, not the message, in fact. They should get to the channel and retrieve the message to consume the message, in fact. A lot of people don't understand the meaning of them, but they are really complementary to the listeners. And now we have message subscribers. They receive a copy of the message. Okay, so during the VDD execution, the VDD will distribute some copy of the message to the message subscribers, right? So you have listeners for fast, subscribers for, let's say, soft notification, and message subscribers to hard notification with the message at all. So we done that. We rely on NetBuffer. NetBuffer is a really powerful tool. I would change the name from NetBuffer to Buffer to be more, I don't know. It's weird. I am using NetBuffer on ZBus. It's not Net, but it's really interesting. And I showed that here just to mention that we use a pool of NetBuffers, and the message subscribers has they have FIFOs, right? So we can put some NetBuffers on the FIFO, and then they can consume the messages. So the NetBuffer works with a kind of reference count. So we can locate message on the heap and make them to take care of it. It's really interesting because we don't need to allocate that manually. So the process is we use a NetBuffer, we copy the message to the heap to keep the stage of the message, because during the publication or after that, you can change the message, and that message, the first message, should arrive on the message subscriber. And we do that for the three of them here, right? And then we send a reference of the NetBuffer to them. And when they receive the reference, they know where is the message. So they make a copy, they unwrap the NetBuffer, and the NetBuffer remove the reference to the heap allocated, right? And put the NetBuffer on the available pool again. And you do that for all the message subscribers. But the latest one, when we don't have any more references to it, the NetBuffer will delete the heap memory. So the user doesn't need to know that, they just receive the message on the message subscriber. This is a kind of under the hood way to work, and I'm going to show you. I was trying to be transparent or something. But also, on that case, we have a copy of the message on all the message subscribers, okay? Some tips about message subscribers. We can also use static allocation for it. If you want to avoid a heap, you can do that, but you must make sure that the message size that you are configuring there will fit, will enough to fit all the messages you are exchanging on that message subscribers. There is an assertion there that helps you if you enable asserts there and you don't have enough room to fit the message. The assertion error will raise some problem and tell you must use at least 20 bytes for that, for example. You must take care of the pool. We have just one pool for all the message subscribers and channels. So it's really a global big pool, and you need to take care of that and make sure that you have enough a big enough pool to make your system communication to work without a lot of failing, right? And another tip here, we now have a different sub-weight, right? We have ZBus subscriber weight message. In that case, we receive the channel, but also the message. And if you are observing two different channels, you must be sure that this message is big enough to hold any of those. So using a union like this would be really easy and straightforward. It's not necessary to define manually the size of it, right? I usually use that like this. So the latest one, and one of the most important, is the highest local priority protocol. With the advent of massive subscribers, we could face a lot of prioritizations problems, right? And if we take a look at that scenario here, we have one subscriber, two listeners, and two message subscribers, and one thread published into the channel. Following that sequence here, and that priority configure here, we could see this kind of thing. If T1 tries to publish to channel A, we would have a channel log, right? A copy of the message, and the listener one execution, what's good. But when we send a message, a copy of the message to MS1, the MS1 has more priority than T1, so it preempts T1, which is not good at all. And MS1 runs and then T1 get back to the MCU and sends a copy of the message to MS2, again preempted, and then it will send a notification to S1, run listener 2, and then after that unlock the channel, and so S1 will read the channel and get the message. We have three problems here. We have a priority inversion, because S1, the highest priority thread, is the latest one to consume the message, which is not good. And we have two preemptions, and we have a listener running after the observers, which is not good at all, right? So to solve that, we implemented a highest lock. So before we used mutex to that, but the priority inheritance was not helping in that case, because MS1 and MS2 are not part of the mutex intended queue, right? So they are out of that. So the priority inheritance of mutex was not working for that scenario. So I removed mutexes and replaced that with semaphores and implement a highest local priority protocol. Is an elevation algorithm, priority elevation algorithm that do things like that. We have a critical resource, and for that critical resource, we have a ceiling priority value. It's not a priority ceiling, right? It's slightly different, because the value is defined by all those tasks that may request, not is requesting at that moment, right? So if we change critical for channel and task for observers, we can see that the channel would have a ceiling priority with the highest observer priority. So you could avoid a lot of those problems I talked to you. So to define that, we have, for example, here we have S1 as MS2 and MS1. MS1 has the highest priority here, so the ceiling priority of the channel would be 1. So with that priority, T1 could publish to channel A without priority inversions, without inversions, without preemptions, and no listeners after observers, right? And sometimes the S1 can be disabled or abort, the thread is abort or something. The channel can be, the channel ceiling, priority ceiling can be calculated again. And in this case, we have, for example, 3, and the channel will receive 1. And that scenario becomes this one, which is when T1 tries to publish to the channel, the VDD will elevate the T1's priority to a highest priority than S1, and everything goes really smooth, right? We don't have priority inversions, preemptions, or anything, right? And after that, the highest priority thread will consume the data, will consume the message. So S1 is the first one to touch it, and then MS2, and then MS1, okay? So we have the HLP requires a priority for the observers, and until now we didn't have this kind of thing. But to do this kind of calculation, we need to attach the subscriber to a thread. So usually we just use a subscriber on one single thread. So we need to attach. We have the detach method function as well, but we need to attach the subscriber to a thread to make sure that the thread's priority is inherited by the observer. Okay, so in summary, we have short VDD execution. We have no priority inversions. The listeners are always executed, are usually executed before the subscribers, which is the intention of it. And if you design the system to avoid inversions, you would not see a lot of overhead because you would not have elevations, which is good. Right, but if you don't want to have the HLP work on your code, you can disable that. It's a configuration that you can disable that, and you can use plain semaphores. But you must be aware that you face some priority inversions, preemptions, and so forth. Okay, and a good thing here that several people talked to me about that and asked that before. Now we can publish to channels, ZBus channels from ISRs, which is good, but we need to make sure that the listeners on that channel are not so long or heavy because you would increase the ISR latency, right? So make sure that, or avoid listeners, or maybe you just use subscribers on that kind of channel. For example, you press a button, the button will publish to some channel. Maybe it's good to have just subscribers there because you'd have a callback calling another callback and so forth, which is not good. And a little about future. One of the things that I'm trying to do is to isolate some pool for a critical part of the system. For example, you have a portion of threads that talk each other, that are more critical than other part of the system. And you want to be sure that always you have a net buffer on the pool for that communication. So we can separate that. It's not implemented yet, but I think that would be there soon. And you can create a heap pool or a stack pool and put that separated. And you can share the same pool with some channels. Would be good to make that more safe or more critical adjusted. Okay. Another thing that I'm working, I'm helping the IoT applications from a team from Nordic to implement the multi-core ZBus, which is a really big challenge. This one is when you have multi-core, you'd have a channel on both cores, and you need to keep the state of that consistent, right? Which is not so easy because you have the other core can be sleeping, or you can have some RP message problem and everything else, okay? And for making that easier, we have two new things added to ZBus. We have the notion, the concept of shadow channel. The shadow channel is, for example, here the payload one is a kind of channel that it's a read-only channel. You can only this core here just can read or receive some notification from the channel, but in this core we cannot publish to that channel. But on this core we can publish on the actual channel, And all the things that happen to that channel will be reflected to the shadow channel. And we have an proxy agent in the middle, right? They know how to talk each other to make that consistency happen. And if we take a look at that and change the medium here, we are talking about mood core, right? But if we change that for two MCUs talking through, for example, UART, you could have mood target, right? You just need to change the medium here, the agent talk. They know how to talk, but you just need to change the medium, and you can have from, you could have from mood core to mood target, which is really good. When you are thinking on, for example, embedded and host, you could have a ZBus on the host talking to a ZBus on the embedded device through a UART, for example, which is really good for simulation, for testing, and so forth. Okay. And the latest topic is what I'm calling Zephyr daemons, right? This is a kind of, I don't know, it's a really long road, but I could see a lot of things, and I think that it's almost time to have daemons on Zephyr, right? And I don't know if everybody, I believe that everybody knows, but a daemon is a service that is running on the background to help other processes to work, in fact, right? So why doing this? We could do that using a common API, command response event, right? And with that, we would have a core for the daemon and an adapter. The adapter could be exchanged to talk to the driver. So we would have a daemon that we could change the adapter to make that more flexible, and we would have a piece of the application running properly, and we can access that like a microservice. But it's not a microservice because it's a thread. But we talk that we can call that a daemon, right? Because it's not outside, it's inside, and it's running to help us. And for example, we could have this kind of scenario where we could have a daemon for MQTT, a kind of DB, or buttons, simple things that we still are programming these kind of things. We still need to do code for buttons, for example, and other things like, for example, MQTT. If you take a look at the publisher sample, you'd have 500 lines, which is not, whoa, 500 lines for a sample to publish something on MQTT is too much, right? It would be easier, because if you go to the desktop, for example, you have Mosquito, pub, and you can do some I don't know, some arguments there, and okay, that's running. So on Zephyr, we have to do a lot of work and redo that every time. I think that all the companies are doing that, almost the same thing, repeatedly. So I guess we can, it's not for everything, but we can find some parts of the code that we can put inside a kind of capsule and make that reusable for everybody. It's almost like that. And it would be like this one. We could have a kind of configuration. We publish to a command channel, and we try to check that on a response channel. And we could publish that, just use a kind of struct and publish to the same command channel, right? So the command would be kind of union with some metadata, and it would work. In fact, we were switching from 500 lines to some configurations and, I don't know, a couple of lines, right? It's powerful, but it's limited. But for the majority of the usage, it's the enough thing, right? I don't know how many companies are tweaking a lot about, I don't know, MQTT or common things, and maybe this is part of it. Okay. So, and I was planning to make the communication interfaces mapped on a kind of interface definition language, I know, ZBus, CDDL or something, a protobuffer, to make that available to other languages as well. For example, we see people talking about using Rust, Python, and Ray, I don't know how to say that. It's a Rust virtual machine that can run there. And if we have a lot of daemons defined internally, all the C part, all the driver part, the hard thing, the hard parts, that's already done on Zephyr would be encapsulated on a really well-defined API with a protobuffer, and the other side just need to access that part. So, for example, an application in Rust would not be necessary to have, for example, syscalls or a lot of detailed things there, because you just need to use a ZBus well-defined API, and you could have just a wrapper on the ZBus and other small things on the system to make that work. So I think that it would help us to make a more, let's say, a more prepared for virtual machines or something like that, okay? So for wrap everything, we have three new features. The observer storage, right? We could do a lot of good things with that. A new kind of subscriber, and a new priority elevation protocol, which took 90 days to get merged. A lot of things to be done at that time. And for now, we have the individual pools to make that. It's a small feature, not so hard to do. ZBus mood core, which is a big deal, and daemons, it's a big deal. But it's a start, okay? And I'll open for questions and okay.
Thank you for the talk. ZBus is new to me, so, and I find that all.
Yeah, it's working, I guess. Yeah.
Sucks. I'll try to. Testing? Okay, that's better.
Oh, that's good.
A little
better.
bit. My question's around the VDED and why that runs from the publishing thread context, and if your idea of daemons could be applied to that to maybe move it outside that publishing thread context to get around some of the limitations on the listeners needing to use that stack and context.
Okay, great question. At first, we had a centralized event dispatcher. In fact, I call that virtual because it doesn't exist. In fact, because it's just a function call on the publisher context. But it was to avoid priority inversions. In fact, because if you have a central entity publishing something, what is the proper priority for that? Because if you have a really, I don't know, low priority thread publishing to something that just low priority threads are involved, you are using a high priority thread to make that. So you are avoid to, I don't know, highest priority thread to work because you're publishing something. So in that way, you could have more different kind of context, talk context without interfering each other. High priority threads talking to each other without interfering in the low priority threads, and the scalability of that is really huge, right? Is okay? Okay. Any other questions? No.
Hi, Rodrigo. Thanks for the presentation. I have a question around the channel definition. When you're defining a channel, do you need to know at that time what are the number of observers and what are their types, or is that somewhat abstracted?
It's separated. It's a kind of when we define a channel, we have a kind of array defined, but in the implementation we have creation, separated object creations, in a kind of list, but it's not on a single list. We are iterable sections for that, right? We have iterable sections, and we can link them one by one, and it's really easy to follow.
One of the things that we'd be interested in having is the ability for the publisher to know how many subscribers it has, so that it could potentially shut down and stop publishing if there are no subscribers. So for a more dynamic context, say you've got accelerometer data and you've got a task that's, multiple tasks that suddenly, have been scheduled to stop. So therefore you want the device to go into a lower power mode and turn the accelerometer, or stop the accelerometer data from continuing to publish that, or even sample. What would you recommend as a mechanism for the publisher to be able to know how many sort of dynamic subscribers there are?
You need to know how many subscribers. The publisher would need to know how many subscribers it will affect.
Well, essentially, like maybe an event or something like that, to be able to notify that the number of subscribers has changed and that number is now 0.
Yeah, the principle is to make that detached, right? It would be not necessary, in fact. But you can use, for example, user data pointer to add some metadata to the channel. It's possible. And you can, for example, make some atomic there, and where you have some observer, you can increment that count. And when you are not enabled, you can decrement that count. And you have also a validator function, which is run before the publication. So if you could have a kind of validation that tries to find out how many observers that function has. If 0, the validator would return false and the publication would not work, for example. It's a way to go, but it will cause error, but you would not publish if you don't have any observers, right?
Okay. Yep.
Make sense? We can chat more if you
I have to think about it a little bit more, whether that could be used to actually shut it down and then dynamically start it again. Yeah.
Okay, we can. Another there.
For multicore, how does the proxy differ to the daemon store you make, or is your proxy a daemon?
Oh, yes, maybe they are the first daemon, right? And I don't know. They are a separated thread that need to work in parallel with all the system, but they're individual and they need to know other agents on the other cores. They need to talk to discover something, and they need to have some information about the channels, the shadow channels and something like that. And for example, when one core wakes up, the agent of that core should ask the other agents, oh, I have 2 shadows here. I don't know, did you change those shadows? Yes or not? You could keep the consistency on that part. But yeah, the daemons are a long journey. It's not for the 3.6 or 2.7, maybe 4. I don't know. We need to discuss a lot more about that.
Okay, thanks.
Does anybody? Okay. Okay, in time. Thank you.